So last class, what we did is we simply started our SAFI training. And just to remind you guys, what is SAFI? SAFI is a structural software that allows us to analyze a structure and then find all the internal forces in that structure under the given load. And you guys know by now that this is, or this step of structure analysis, it is just part of our design. We cannot really proceed to designing a member without knowing what are the internal forces going into this member. So the last class, what we did is we really, progressed so much in SAFI. And if you guys want to remember, we are able to create grid lines, add joints, and then joining those joints with members, and then assigning those members properties. When I say properties, I'm referring to two different things. One is the material. Number two is the shape of the cross section. So this is assigning the properties to my member. Then once you finish this, you also add the supports wherever the supports will be available for the structure. Then the next part is creating the loads, which involving creating a name for the load and then assigning specific value, whether it's a point load or a uniform load to a joint or a member. We were really about to finish this part. So the last step that we need to do before we start the analysis is we need to create what we call it load combination. Now, I think it's good time now to kind of refresh your memory about load combination. That's why I'm going to switch back to my SAFI demo. So I'm not sure if you guys had a chance to go to the or use this demo to analyze your structure. However, if you haven't, then I think I already kind of copied the table from the National Building Code or from Alberta Building Code. And so what you see on my screen right now is something called load combination. It is something you will see probably every class in my class for the entire year. The idea here is very simple. The idea here is when loads act on the structure, they don't act individually. So they act together on the structure, or except for the dead load, because simply dead load, it exists and it doesn't go anywhere. However, live load, it can come and go. Wind load same, snow load same, earthquake is the same. Now you can see we don't have one load combination. We have so many of them. Even if we take one of them, it will create and generate for us sub-load combination. Something also I have said it, and again, it's a good time to remind you, when it comes to load, there are, for a specific load combination, there is something what we call it principal load. And this principal load is the load that dominates this load combination. For example, in load combination number 2, which is here, I'm going to probably draw a line here. So this load combination number 2, you can see this part here is your dead load. Again, dead load is there and will stay there forever. However, in this load combination, obviously, the live load is the principal load. And we're seeing here, you can see the factor, it's 1.5. We're seeing here that live load dominates this load combination. With this principal load, there is a companion load, which is not really dominating the load combination, which is in this case, you need to take either 100% of the snow or 40% of the wind as a companion load. So hopefully, guys, this tells you what do we mean by principal load and companion load. If we take another load combination, which is number 3, you can see what happened here is the principal load is not the same. So it is not live load anymore. However, in this load combination, snow load is the principal load. And for the companion load, it could be either live load 100% or 40% of the wind load. Guys, remember, in my discussion previously, I was referring to something called load factors. And in this table here, where are the load factors? it is 1.4 or 1.25 or 1.5 or 1 or 0.4. Those are what we call it load factors. Okay, guys, load factors, so you know, they come from the probability of a load. So, and those load factors, uh, within the same specification or code, it can change from one version or publication to the next publication. I can tell you back in time in 2010, so this was what's happening. I'm gonna box out those numbers. So those number in 2010, they were not really 100%. It is 50%. So if you check the National Building Code 2010, and from that we have adopted the Alberta Building Code 2014, you will see in 2014 EBC, you will see this number was not 100%, was even 50%. However, it is based on performance. And remember, this code is written by not only scientific or research people, but also from people from industry and people they have like so much experience in construction. So looks like the 50% of snow or 50% of the live load was not really giving a satisfactory design, and that's why they had to change it to this number. Also, if you travel to the States and work in the States and you do some design in the States, you will see those numbers are not the same. Those are again local numbers. There could be slight change. For sure, it's not going to be 20 or 30. You will never see this 1.5 as 20 or 30. But I can tell you in the American code, this number is 1.6, which means they are a little bit conservative. They add more live load to their design. Okay, for us as designer or engineer, this is provided by National Building Code and we have to follow. Now, one thing also before I switch to my SAFI, I know that this question was asked, Tahir, when I try to analyze my structure, should I only perform or analyze a structure under load case number 1 or 2 or 3 or 4 or 5 or 1 and 5? The idea, guys, here, yeah, those are the possible and critical load combination. Your ultimate goal is to make your structure safe under any of those. When I say any, it means you have to try all of them. Again, if you do that manually, it's going to be like difficult. When you do that with the software, you will see how easy to do that. Okay, then let's do it. So I'm going to switch back here to my SAFI. And let me show you on how to create load combination. Very, very simple. You go from menu table, and then you go down to load combinations. And when you hit load combination, it comes with this window. And you can see when you look at this window, so far there is only one load combination, only one load combination. You can see on the bottom left here, the name, it's called untitled. The factors, all of them, they are 0. It means we're multiplying all the loads by 0. So that's not really good for now. So I'm going to show you right now on how to change that. Let's do the first one. And if I switch back to my table, you will see the first one is we will be analyzing the structure under 1.4 dead load. Very simple. You go here, you double click on this number here, which now is 0. You turn it into 1.4. What does it mean, 1.4? It means, hey, software, please multiply my dead load by 1.4. However, all other loads, multiply them by 0. So don't include them. Next, please don't forget that you come back here to the bottom left corner where you see the name. You just go ahead and double click and it opens up untitled. We go ahead and say 1.4D. So we have changed the name so that it matches what it does. Okay, now hit OK. Congratulations, you have made your first load combination. We have to do more than that. So I'm gonna go ahead and you can see here there are some controls on the top right. I will go probably through some of them. For example, this one is very intuitive. If you don't like a load combination, you simply click on the bottom left key here and then hit delete. And if you wanna create more than one, you can see this button, it says add a new tab. It means add new load combination. Something also I want to mention here before I do the next one is on the top here, there's a load combination number, ID, which is sequential, which means if I say create for me another one, this number will switch to 2 and 3 and 4 and 5 and so on until or unless you want to change that. Just below enable, it means analyze it. It means solve, please find for me the bending moment. Otherwise, if you uncheck this box here, it means yes, the combination is there, but please don't find the bending moment for that. Sometimes if you have so many, you want to try some of them, you just say disabled. Number 2 or below, you will see load combination type. I think we discussed so far that in our design, we need to think and consider the structure under two states, One state is called ULS, which is ultimate limit state, and then another one called SLS, serviceability limit state. So those in the table, all those combinations in the table, those are ultimate limit state combination, which we use them to find our ultimate or factor depending moment and shear force, which we will do the design later on based on. As you guys remember from maybe a week ago or 2 weeks ago, I said when we design a structure, we're not only focusing on failure, we also focus on the performance of the structure on a daily basis, which means deflection, vibration, cracking. Anyway, so guys, so if you drop this menu, you're allowed to change the type of the combination from ULS to SLS and the opposite. Okay. Now, let me show you on how to create the next one. So I'm going to come back here. I'm going to say add a new tab. And it says you want to make a brand new one from scratch, or you want to duplicate, copy, because sometimes it's kind of faster if you just copy and then modify. I'm going to say, you know what, it doesn't matter for me, this one, it doesn't matter. I'm going to say, let's say yes. You can see right now I have two different tabs down here. Okay, I have the 1.4. I have another one called untitled. So I'm going to look at the table one more time. I'm going to go to my load combination number 2, where I'm going to use 1.25 the dead plus 1.5 the live. And then remember, I have no snow. In this problem, if you guys go back to the tutorial of SAFI or the demo, you will see I have no snow. It means the structure is somewhere on the earth where we don't get any snow. Okay. Now, which means, guys, because I have no snow, it means I just combine my 1.25 the dead plus 1.5 live, and we have no snow, so this out of the business for now. And I'm going to combine this with 0.4 the W. Remember that for the wind, it can blow either from the left or from the right, and that's why this will create two sub combination, which means 1.5 the D plus 1.5 the live, and then this one we have two. We have wind left and wind right, and this will create two sub combination with wind left and wind right. Let me show you how to do that. Okay, let's do that here. So first of all, I'm going to change the name. So double click on untitled. I'll call this 1.5D plus 1.5L plus 0.4 wind lift. Okay, guys, take a look at the name, and you will see you're supposed to expect what's going to happen to those numbers. So those numbers right now, as I said, 1.25, 1.25 the D. The live load I should multiply by 1.5, and then the wind lift is 0.4. Okay, and remember, there is no wind right. They don't act together. It's either wind left or wind right, not both of them on the same time. Remember, look at this. So again, as I said, copy, you can see the number is already switched to 2. If I want to call it 200, that's fine, but typically I'll leave this one as 2. And still it's ULS, ultimate limit state. Let's go ahead and do this. Let's go ahead and then simply copy, duplicate. All you have to do is just do this to 0 and this one to 0.4, okay? And so you can see all I did is I just copied, and I still the dead load is 1.25, the live load is 1.5, and the wind right is 0.4. However, wind left is equal to 0. Name, please, name. So the name is 1.25D plus 1.5 live plus 0.4 wind right. Okie dokie. So now we have 1, 2, 3. We have 3 load combination. Guys, let me ask you, are we done? So let's see if we get some input for some marks. Okay. Show your hands, please, if you think that we're done. That's all I need to do. Okay, Jelly, go ahead.
We are not done. We have to make 5 combinations.
Okay, looks like you studied my tutorial, but thank you so much. Okay, no problem. You know what? Even I consider this effort, so here is a mark for you. Okay, so thank you so much. So it's true. You can see, and I'm gonna tell you why. Okay, why? Because simply in load, I have done load convention number 2. However, I need to go ahead and then do number 4, and I don't have number 3, and I'm gonna ask you why. Why I don't have number 3? Any input?
Because of the snow.
Sir, what do you mean? What do you mean? And your name first.
Mahdi.
Mahdi. Okay, why Mahdi? You think that we shouldn't do number 3?
Because it's multiplying 1.5 by the snow load, which we don't need, and it's under the category of
You know what? I'll give you, Mahdi. I'll give you a mark here. Okay, I'll give you a mark for sure. You deserve that. But I'm gonna reformulate what you said. So guys, number 3, load commission number 3. You can see the table here. It deals with the snow load as a principal load. However, here, as I said, this is a structure in some areas on the earth where we get no snow. It means there is no point of view because snow is 0. Snow is 0. So there is no point that you try this load combination. Okay. If we have wind, then we go to number 4. Let me show you number 4. So guys, I'm asking you, number 4, you think is only one combination or will it generate 2 sub combination? What do you think? My question is one more time, when we create load combination number 4, does it generate only one load combination or 2? Okay, let's see. Toyib, please.
Just one.
Just one. Okay, thank you, sir. Next is Jelly. What do you think?
We have to make 2 combinations because of the direction of our wind, which is left and right.
Thank you so much. Like, here's a couple of marks for you.
Thank you.
Thank you. Okay, amazing. Okay, so guys, that's true because wind has 2, like wind left and wind right. So this will generate basically 2 sub combination. Let's do that. So I'm gonna go ahead and copy. Yes, copy. And then I'm gonna call it here. I will call it here 1.25D, always there. Plus, remember, right now the wind is the principal. It means 1.4W left, and because we have wind right and wind left. Plus, let's go look at the table. So in the table, we use 0.5L or 0.5S. Remember, since 0.5S, there is no snow, so it's only 0.5L, which means I come back here to my SAFI and I say plus 0.5L, and okay. Now, remember, please don't forget, it's not only about the name, it's about the factor, which means the live load here is going to be 0.5 instead of 1.5. And then my wind left is here is 1.4. And then here, lastly, this number is equal to 0. This number is equal to 0. Okay. And then let's do that. Let's go ahead and say copy and change the name. So this one is 1.25 dead plus 1.5. Sorry, 1.5 wind right, and then plus 0.5 live, and then hit OK. And then for the factors, you can see the same. 1.5 is okay, is great. 0.5 is great. However, this number should be 0, and this number is 1.4. And now you can see I have finished 5 load combinations. Now let me ask you, am I done? Like, are those the only load combination I should analyze and see how my structure behaves? Let's see. This is a good question, by the way. It's not easy, so please try to contribute an answer. I'll say my question one more time. So far I have total of five load combinations. My question for you is, am I done? Should I just go ahead and analyze, or I'm missing some combination? And if I'm missing some, why, or what I'm missing and why? And this is a good mark. I'm going to give 5 marks for that. 5 marks. Okay, so we have one already. Anyone else wants to raise the hand? Okay, guys, I'm going to go with Brody. Brody, go ahead.
I believe you're missing the seismic one with the earthquakes.
You know, it's to be honest, maybe yeah, if it's a true design, probably yes, I will go ahead and find the seismic on load commission number 5. However, if you read the problem, I have never specified seismic load, and sometimes the case, sometimes in a very static or stable area of the earth, close to the ocean, we get lots of earthquake. However, the more you're far from the earth, from the ocean, you're kind of very safe when it comes to earthquakes, and probably the wind will govern. So, but however, thank you so much for this input. Guys, anybody else who has some input? Jelly.
I think that's all the load we're going to have, and the rest we can neglect it because we really don't design earthquake in this area in Calgary.
Okay, thank you so much. Guys, look at this, please. So, you know, if I finish and I analyze, what you see here is yes, I'm done with this table, by the way. I'm not missing anything. I have done all of them. However, really, we cannot, I mean, by now, we're not finished yet. Because what you see so far is simply an ultimate limit state. For example, if we finish the analysis, to be honest, you cannot tell your deflection. Yes, you can tell the deflection, but in ultimate limit state. And remember, when the structure is about to fail, ultimate limit state, we don't care deflection. The structure is already about to fail. Okay. However, so look at this, please. So I'm going to show you right now. We have to see and analyze the structure under serviceability limit state. And remember, they serve a different purpose. So the ultimate limit state has a function, and their function is tell me what is the maximum bending moment, what is the maximum shear, what is the maximum axial force to design my member. How about SLS? It's different job. It tell me how much my beam is going to deflect under unfactored load. Are you guys following? So as I said before, what we had so far are ultimate limit state combination. We use them to find the maximum bending moment and shear and axial force. However, the designer should look into a different state, which is serviceability. Serviceability, it doesn't really, we don't need to factor our load. We're going to use today. So today, it's only dead load and live load without any factor. It's wind without any factor. So let me show you. I'm going to create here another load combination. I'm going to say, okay, yes. I will just change the name to dead plus live. No factor. Those are unfactored loads. Okay. And then hit OK. And just change. So this one number will be 1. And this number is 1. And this number is 0. And this number is 0. It means, please analyze my structure under dead and live, which is happening every day. That's every day, not when the structure is about to fail. Okay, so for this one, I'm not going to take any moments. So from this one, I'm not going to come up with any moments. I don't care the moments here because I'm going to design an ultimate limit state. However, from this combination, I'm going to check whether my deflection is good or bad. Now, let's go and do a couple more. So I'm going to say, okay, you know what? Here is another one. I'm going to say yes. I'm going to say call this one wind left. You know what? I don't want to be, I want to be, I give you the right information, but to be honest, what I'm writing right now is not the right information. Some of you may think we need to find the deflection or the sway of the building under the wind, but you will see in my class, probably not today, but sometime next class, we do not do that. We only find the deflection under 75% of the wind load. Okay, only 75%. And I'm going to tell you that when time comes, why 75%? Why not one? Okay, but for now, just maybe just to follow this one, I'm going to do it wind left. While I'm going to tell you when the factor for wind is not 100%, it is 75%. Okay, so 0.75, and then hit OK. It means this number is 0, this number is 0, and this number is 0.75. And then finally, last one. I'm going to change one here to 0.75 wind right, and then hit OK. And so this number is 0, and this number is 0.75. And I'm sorry, guys, like I've done some mistake here, which is I should have done is simply go back. I'm still here, so I'm going to change this one to SLS, and I'll go back to this one. I will also change it to SLS because those last two and this one as well, it's SLS. Okay, so the last three, 1, 2, 3, those three, they are serviceability limit state. And as I said, we are not going to use them to find any bending moment. The purpose of adding those is to study deflection, sway, and deformation in your structure. Congratulations, we're done. I want to say something before I hit OK. So guys, you can see those are coming from building codes, and the software, uh, it can create those on your behalf through a wizard. So you can see here on the top right here, there is a wizard where you just have to say, okay, I want to follow National Building Code of 2010, and the software will automatically generate for you all those load combination automatically. However, the thing is, the software until now doesn't have the latest version of the National Building Code or the ABC, and that's why we have done it manually. But this option is there. Now, guys, we're done, so I'm going to hit OK, and we have now all load combination. Guys, let me ask you, any questions so far? Any questions so far, Mahdi?
When you pressed SLS, you selected the option. It asked you if you wanted to verify direction. Do we need to verify it?
There is more to that, because simply you can put a limit on the deflection limit. For example, like the length over 360 or 240, like what you learned in steel. But I'm going to do that manually. I'm going to look at my deformation and show you, for example, it's 5 millimeter. Is that acceptable or not acceptable? Okay. So guys, for now, any question regarding load combination, what they do and what is the SLS and what are the ULS load combinations? Okay, before I hit OK, one more time, it's very important. We do different states, ULS, SLS. ULS for failure, maximum shear, maximum bending moment, maximum axial force. SLS is for deflection. So I'm gonna show you right, like after we do the analysis, when I look at those load combination, I will when it comes to SLS load combination, I will not find bending moment. I don't care, because I don't care. I'm gonna look at this load combination and see what are the deformation and the deflections under SLS. If I wanna get the bending moment, then I have to find what is the worst among those 5 ULS. Okay, dokie. Now let's go to our SAFI. Guys, so far we have done all the steps. So it's time to do the analysis. So how we do the analysis? Very, very simple. From the menu analysis, you just go ahead and you say run, or simply hit the F12. So this will start your analysis. And then before you start analysis, what happened is there are some parameters here. And to be honest, I would call those one are kind of very advanced parameters. I'm gonna just, maybe say something on a very high level without going into deeper details. You can see the analysis that I'm gonna do right now. It is called static linear. If you drop this menu here, the software provides a more complicated analysis, which is not really very common. One of the kind of very interesting analysis is called static B delta. And guys, for this kind of analysis, what happened is it is kind of iterative, like the software will put the load, and then when you put some loads on your structure, the structure will deform. And in general, for most of our structure, this kind of deflection or deformation doesn't really change the internal forces. However, there are some structures like cable stay bridges or suspension bridges. Those are very sensitive to the deformation, and the deformations are so high. And if you use static analysis, it doesn't give you the right answer. You have to do it in a way you load your structure, it deforms, then you put the loads on the deformed shape. So the internal forces will change and the deformation will change. So you can see it's kind of iterative until your solution will converge. Anyway, so this is what just a kind of an idea to tell you that the software provides a more complicated analysis. In general, for you guys, it will be always static linear. And there are some other settings here in terms of number of iteration and the threshold. So basically for you guys, you don't have to do anything with this, just accept those default parameters. Now what you have to do is run the analysis, and typically before every run the software will ask you to save. Of course, yes, save please. Now what happened is the software will do all the calculations and will show you here kind of a brief log of what was going on. Okay, so at the very end you can see analysis completed successfully. It means nothing was missing, everything goes okay, and I have now all the numbers. Guys, missing any of the steps, it will give you an error. For example, if you start to analyze and you completely forget about load combination, here we go, error. If you start analysis and you forget completely to assign the member properties and material, you will get some errors as well. Okay, so please make sure you follow the steps on my tutorial. It means don't miss any of those steps, then I guess your analysis will be successful. By the way, so you know, it doesn't mean that the analysis is successful. It means your results are correct. Would you agree? Would you agree if I say that one more time? It doesn't mean that you get this statement at the very end. It means analysis completed successfully. It means your results are correct. Because sometimes we have a mistake in the input, and because we have a mistake in the input, sometimes we get some errors in the numbers. Okay, but the software is able to find your wrong numbers. Okay, anyway, I'll try to touch on this one shortly after we try to find our internal forces. Now, any questions so far? Any questions so far? Okay, let's close this window, and then let me show you on how to display your results. Okay, now, guys, look at this please. On the right side, you can see here on the right side, there is a toolbar. On the right side here, where I'm pointing right now, there is a toolbar, and this is called results toolbar. Okay, this is how you can show the results of the analysis. Sometimes for unknown reason or by mistake you close this one. I guess you can revive it one more time. In case you don't see it, you just come back here, I think, to tools. Please be patient, I think. Yeah, it's here. It's under analysis, and there is something called the view/hide results bar. So if this guy on the right doesn't exist or hidden, then you go ahead from menu analysis, you go down to view / hide results bar. Okay, since I have it here, so I'm good. Okay.
Tahir, I think you're not sharing your screen.
Excuse me, like, could you please mute yourself? It's very noisy here. So I'm sharing my screen. Looks like you have a problem, sir. Okay, so I'm sure that I'm sharing my screen because I have here a red box around my screen, so it is shared. Okay.
Yeah, I can see it. You're sharing it.
Oh yeah, thank you, sir. Okay, so what happens here is as I said, in order for you to start showing your results, we need that. It's a must. You must show your analysis or results bar. For any, if you have closed this one by mistake, then you go from analysis menu, and then you go down to view / hide results bar, and it should be okay. Now I'm going to show you in steps how we show the analysis. Number one, on the top, very top of this bar, there is something called combinations, and the tooltip says load combination, which means which load combination you want to show the analysis for. So if you click on this button here, you can see I have here a window where simply it shows you all the load combination you have made so far. And you can see we have like a total of 8. And from number 1 to number 5, those are ultimate limit states. Number 6 and 7 and 8, those are serviceability limit states. And also, so you know, if you have done it right, just by checking on those, you will see by just clicking on this button, it just marks for you on your behalf all the ultimate limit state or serviceability or even clear all. Okay. Now, I would probably, you know what? I would probably show you something, probably this one here. So this one here for now, or maybe this one. Let's do this one first, which means what is the bending moment under bending moment and shear and axial force under 1.4 the G. Once you're happy with this and you chose a specific load combination, or maybe you choose 2 or 3 or 4, that's up to you. You can choose even all of them. Okay, but by the way, showing all of them for the purpose of teaching is not really a great option. You will be confused. So I'm going to show you only one at a time. For now, I'm going to show you the 1.4D. You hit apply and hit OK. Now you can see nothing happened. You can see by now I only decide which load combination. Number two, you need to check this box, because this box here, it says hide or display selected analysis. So let's go ahead and make sure we check this box. And you can see once I have checked this box, which is here, you can see there is something has happened. Something has happened. And now we can see there is a red thing together with the black one. Okay, question for you for probably a couple of marks. Okay, couple of marks for you. Guys, when I showed this, what do you think this line or shape represent? What does it represent? The red line.
The buckling of the posts and the beams.
So sorry, I mean, who is that? Is that type?
Dominic. Sorry, I didn't raise my hand. I forgot.
Oh, I'm sorry. Okay, no problem. No problem. Okay, so Jelly, go ahead, please.
No, I have a question. But to answer that question, that is the deformation of the load member.
Okay, let's see, Toyib. What do you think, Toyib, about this red thing here?
I think the horizontal one is for the deflection, and the vertical one is for the buckling.
So you mean that this line is for deflection?
Yep.
Okay, let's see number 3, which we have. We had number 3. Did we have somebody else? Dominic, did you want to say something?
Toya basically said what I said. That's what I wanted to say.
So can you say it again one more time, please?
So the posts are buckling and the beams look like they've been deflected, and that's what the red lines are showing, the result of the load.
Okay, sir. Thank you. So guys, all of you, you were correct. So we have here, we have Dominic, we have Jerry, and then we had Toyib. So the three of you guys have done it right. So, however, this is not buckling. Buckling is a different analysis, and it's not really the buckling. So what you see here is the deflected shape. So what you see is deflected shape. Okay. Now, why I'm showing deflected shape? I'm going to show you why. Because simply after you check this box, and then the next button, it says display results option. So if you click on the next button here, when you click that, those are whatever you mark here, this is what will show here. So you can see there is only one thing which is currently marked, which is deformation internal. So if I uncheck this one and hey, apply, hit OK, you can see there is nothing, because simply on this window here, there is nothing is marked. Okay, so whatever you mark here, you're going to see the diagram for. Okay, dokie. Now, let me show you the bending moment diagram. And you can see here, those are the forces. So if you are interested for reactions, so your reactions are here. Okay, in this box here, there's something called support reactions. Stresses, which is not really our scope right now. However, we're either using deformation or internal forces or reactions. Other than that is more complicated, or maybe we haven't done this yet. Okay, so let me show you. For example, if I go ahead and say MZ, and I know some of you will ask, why MZ? Why the moment is MZ? Look at the bottom left corner and you will know. The X is going in blue to the right, the Y is in green and going up, and Z is to your face. So the moment of this two-dimensional structure is simply around Z. Look at, do the right hand rule, and you will see the moment is around axis Z. Now let's say apply and hit OK. Now I'm going to show you something. It's not really the topic now, but this one right now is kind of confusing, guys. It's very confusing because it shows so many things together. Here on this side, you can see the loads, 15 and 6, those are the loads. And this curve here, this is the BMD, or bending moment diagram. And that's why, to be honest, I would like to clear this one. I'm going to show you right now, can I control everything in this sketch? Yes, you can. I'm going to show you on how to hide, show, change scale, change text in one location. You can play with this diagram in terms of scale, in terms of text, in terms of show or hide from one place. It's called display option. Very, very important. Okay. So how to get access to the display options? Please watch this. You go from menu view, and then you go to display options. Again, why I'm doing this now? Because what you see right now on my screen is confusing, because it shows you so many things on the same diagram. At this point of time, I don't need the load. I want to look at only the bending moment. So please look at this. I'm going to say display option, and I'm going to show you right now. We can simply hide and show, change scale, change text, and so on. You can see there are so many tabs, and I'm going to come back to here several times today, several times. But for now, we'll talk about visibility. It means show and hide. So you can see there are so many things you can show and hide, like, for example, joint number, member number. However, right now, looks like I'm interested to hide my loads, So we click here on loads, and then on the right side, you can see show loads is checked. And as soon as I uncheck this one, guess what happened? What happened is I'm not really showing any loads. Please watch on the back when I hit OK. Watch this side when I hit OK. If I hit OK, see what happens? We don't see any loads, so my diagram is more clear. It's more clear right now. Okay, now, guys, what do you think? What do you think? I know you have little experience in structure analysis, but does this make sense for you? Like if you put loads, dead load only, gravity load on this frame, do you think the numbers, not the numbers, I'm not asking you to say the 204.91 is correct or no. I'm not asking you that at all. But I'm asking you, do you think this diagram, it makes sense for you? I know it's kind of difficult question, to be honest, and I don't blame you. When we draw the bending moment diagram, we simply, it has to make sense of us. And when I say it has to make sense for myself is by looking at like for example, the tension and compression, because I know what you learned in last year, first year, that you guys draw the bending moment on the compression side. However, as I said in my class, we better do it on the tension side, which means anything you see on my screen, it follows what I said. Draw the bending moment diagram on the tension side, So let me ask you, just go section by section, and you will see what I mean. Look at this joint here, this joint here, okay? Now, what do you think? You think this bending is correct, this direction, this side is correct, given that it's on the tension side, or no, that's not correct? What do you think?
That is correct, based
Okay,
on the column, because it, first of all, the support in the column is pin, so there is no moment at that, so the moment is on the top.
okay, great, thank you. I'm going to show you also, listen, I'm going to show you something so kind of you can follow what I'm saying. I'm going to show you the deflected shape. So I'm going to go back and mark my internal internal deformation, hit OK, and let me ask you right now, if this connection here at grid line A and grid line 2 is trying to do this way, huh? So this is the deformed shape. I wish I can change the color, but I don't know, and I'm not sure if I can do that right now. But I want you guys to imagine about this connection here. This connection, obviously, under the load, it is trying to be less than 90 degrees. So start from 90, and under the load is going to be less than 90. You can see the bending moment is on this side. It means the tension fiber will be on this side and this side as well. Okay, as you go mid-span between the columns, what happens here for those fibers in this section here, the tension will be on the bottom, where the bending moment, you can see the bending moment is happening at the bottom. On top of the support, you can see, so my curved shape or my deflected shape is going to go, it has to go to this point, okay? And again, it's going to go back, which means on top of the intermediate column, it is going to be negative bending moment. Negative bending moment, like the top fibers will be in tension. Guys, this is something, you know, you want to check. I want to tell you something really. When we input wrong numbers or wrong direction to the software simply doesn't know. It just follows, trust you, and follow all your input, and it gives you the results based on your input. So if your input is wrong, your results will be wrong. And that's what I said. It doesn't mean that it says analysis successfully finished or something like that. It means your numbers are correct. Okay. So it is your responsibility to go ahead and make sure that your model is correct. I will try between now and until the end of this discussion to show you how can I do that. How can I verify? How can I ensure that my numbers were correct? Okay, let me show you guys. You know what? I will just go back here, and I said, okay, you know what? Don't show me internal forces, don't show me bending moment. However, show me reactions, RY. Okay, show me RY. Reaction in the Y direction, hit OK and hit OK. Now, guys, let me ask you, do you think if I have RY, it helps me to check my input? And how? 5 marks. 5 marks. If the software already finished all the analysis and simply figure out for me the reactions at this point and this point and this point. Do you think, based on those 3 numbers, I kind of check my input? What do you think? Jelly, what do you think?
Can you please rephrase your question again, sir?
Okay, I said when we input wrong information to the software doesn't know. For example, if I change my dead load from 15 to 10 by mistake, then it will find my bending moment and the shear and the reactions based on 10. It doesn't know exactly what was supposed to be like the dead load. If you change the sign, for example, from -10, which is supposed to be going down, to +10, again, it doesn't know. It will just follow you and trust you and give you the bending moment and the shear and so on. I'm saying here as a designer, your responsibility is to make sure that you do some visual checks to kind of make sense of your model. Now I said, let's go ahead and show the reactions. So I'm showing the reaction right now, which is 91 on the left, 219 on the middle, and 66 on the right. Those reactions, can I use them to verify that my input was right?
Yes.
How, sir? How?
You can do it manually, or you can make a command. If you can make a command to show just the shear force diagram of the system.
I cannot really 100%, I'm not sure 100% of what you said, but let me ask you, answer this question for the sake of time. Guys, look at this, please. What if I add the three numbers? I need somebody to help me, maybe if you are interested, add the three numbers. The 219.79 plus 66.8 plus 91. And remember, I'm referring here to, look at this. I'm showing the reactions for 1.4D, okay? And let me show you, if I go to my tutorial, let me go to the tutorial. So the tutorial said here that I'm trying to solve this problem, and the dead load is 15. Let me ask you, if I multiply 15 kilonewton per meter times 18, 15 times 18, why 18? Because the entire frame span is 18, and every meter it has 15. So if I multiply 15 times 18 meter, I'm going to get the entire load going down. Okay, let's do it. Please do it with me. I need to multiply 15 kilo newton per meter dead load times 18, and then times 1.4 because this load combination, we're adding 1.4 dead load. So please put this number on the side. And then if you add those three numbers, what is supposed to happen? Tell me what's supposed to happen if I multiply 15 times 18 times 1.4 and I add those together. What should happen? What do you think? Answer, please.
Those numbers should be all equal. To the total point load of the one on top. The 15 times 18. Then the result of that should be equal to all the reactions in the at those pins.
Thank you so much. You are awarded 5 marks.
Thank
Guys,
you.
remember, look at this. Your structure, I know it's, I'm going to show you like how many times statically indeterminate, but I'm asking you, whether it's determinate or indeterminate, should we end up with the sigma forces in the y direction equal to 0? Because remember, at the end of the day, this is stable. It means it doesn't move anywhere. It means the summation of the forces in the y direction is equal to 0, which means there must be a balance between the applied load and the reactions. So this is one of the checks, only one of the checks, that if I add 66.8 plus 219.8 plus 91.3, what happened is this should equal 15 kilonewton per meter, that's dead load, times 18 meter, which is the entire span of your frame, times 1.4, because simply the combination is 1.4 the D. Okay, so those are under 1.4 D. Those these should balance each other. It means equal. So the summation of the three should equal the total load going down. Okay, so this is one of the checks. I'm going to show you another check that I myself always do it. I'm going to show you. So for example, watch this, please. I'm going to change my combination And instead of 1.4, I'm going to say it 0.75 wind lift. So I'm going to see how the structure will behave under 75% of wind lift. I will hit apply and OK. I'll go back to here. I say, OK, you know what? Forget about, for sure there should be a balance in the X direction. So if I show RX, OK, if I hit OK here, guess what? The wind going to the left, the wind going to the left is equal to read. So look at my tutorial here. So the wind lift is equal 10. Okay, so 10. If you take 75% of 10, so this will be 7.5. 7.5. If you go to your structure and if you add those three, they have to come to 7.5. Okay, because there is a balance in the X. Same for the Y. So reactions is one thing to tell me whether I have done it right. Number two, deformation. Watch me, please. I'm going to change here. Please don't show me reactions. However, show me internal forces. Hit apply, hit OK. Guys, what do you think? What do you think? If I blow my wind to the left side, the red line, does it make sense? So my structure would sway to the left?
Yes, makes sense.
Okay, now let's try to the other one. I'm going to go back and say combination. I say, okay, you know what? Not left, do the right. Hit apply, hit OK. Look at the structure. So the structure right now is to the right. And I think we've done already this exercise. If I change to 1.4D and not this one, I'm asking you guys, do you think this deformed shape, it makes sense for you?
Yes.
Yes.
Okay, guys, perfect. So that's exactly what I'm trying to say is please, when you do any structure analysis, not right away just and see what's my forces, what are my deformation. Not really. Verify your input. Make sure that the model makes sense for you in terms of reactions, in terms of deformation. I'm not asking you to do, for example, to tell me whether the 2 millimeter here on this side is right or is wrong. But by looking at this deformed shape, it tells you, you know what? Probably the direction of my wind was right. And you look at other one, okay, yeah, probably this was right, okay, and so on and so forth. So I verify your input by looking at stuff like reactions and the deformed shape. Okay, guys. Now I want to show you something also, something very interesting, which is you will need in your assignment, which is, let's say, you know what, you know, the deformed shape, yeah, it makes sense, but I cannot visualize it very good. So can I simply exaggerate this one? Can I magnify it? Yes, you can. Obviously, the scale right now is not a good scale. If you want to see better, I'm going to show you. Same thing. As I said, I'm going to go to this place several times today. If you go to menu view, you go to display options. And if you guys remember, did I use display options today? Yes, I did. Okay. I went here before, and my intention that time is to simply hide my loads. However, if you want to play with the scale, it means you want to magnify your bending moment or you want to magnify your deformation. Watch this, please. You come back here and come back here. And probably there is other control for colors and sizes and text. But for now, let's go to the scales. So guys, look at this, please. When it comes to the scale, right now, I'm looking to change the deformation. The deformation, it looks right, but it's very small. So watch me, I'm going to click on analysis because I really want to play with the scale under analysis of the results. Now you can see all the scales are mentioned here. There is a scale for displacement, for velocities, acceleration, forces, moment, axial force, shear force, torsion, and so on. Now, can you guys guess which number among those should I change? Take a moment, take your time, look at all those numbers. Now I'm showing on the background, I'm showing deformation, okay? Which one you think I need to change? Any help?
Would you change displacement?
Who's that?
Mehdi.
Thank you, sir. Yes, you're right. We changed the scale of the displacement. Okay. Now, I want to give you marks. So if you can answer this one, I'll give you another mark. Okay. So Mahdi, what do you think? This number right now, I don't like it. You know, obviously this number 10 is not okay. So should we increase this number or decrease this number to make it bigger?
To make the deflection bigger, like the
More obvious, to magnify deflection on the diagram in red on the back. Okay.
oh, then you'd go smaller.
Okay, again, thank you so much. I think that's right because you guys have to read this part. This part is the clue here. The answer is here. The way we read this one is we say right now we're showing every 10 millimeter as 1 meter on the back. Okay. Okay. If I want to make this larger, all you have to do is it means, for example, let's say I want to double that. I'm going to make it 5. So how the way you read it is no, make every 5 millimeter as 1 meter, which means the 10 will be 2 meters. Okay. So this is how we magnify our diagram. Let's hit apply and hit OK. And obviously, see what happens. My diagram is more pronounced, is magnified, and we can see better. And by the way, this applies on anything. For example, if I show bending moment, let's do that. So if I come back here and I say, you know what, I am not interested in bending moment, show me MZ, bending moment diagram. Apply. Hit OK. Let's say that this diagram is not really you want to magnify it. You want to magnify it, okay? I'm going to show you how. One more time. I'm going to go from menu view, display options. As I said on the skills tab, we are still under analysis. And you can see this section here. This section here is under member results. Axial force, shear force, tension, and so on. So you can see my bending is here. Okay, right now, every 100 kilo Newton meter is drawn as 1 meter. If I want to magnify it by factor of 2, guess what? This number should be 50. And then I'm going to say apply and OK. And look at the diagram. Right now, the diagram is bigger. It means magnified. Guys, you will need this in your assignment. Okay? On your assignment, I gave you a structure. You need that. Okie dokie. Let's me, before I forget, Mahdi, I owe him a mark.
5 marks.
Okay, 2, Mahdi. Okay, no problem. 2. Okay. Now, again, we're almost very close to finish, and then I'm going to give you a break. I'm sorry for being making so long. Okay. So, guys, if you want to, for example, you can see if I go back and say, okay, you know what? No bending moment. Show me, for example, axial force. So Fx. So this axial force. You can see all I have to do is, go back to the type of results and then hit apply, and you can see this is my axial force. Does it make sense for you? So this column here has 219 axial force, and this is 90, and this 66. Does it make sense? I think it does. And I'm, for the sake of time, I'm going to save your time. This column in the middle, simply it supports more of the roof beams. Okay, so you can see if this is 10 meter, so typically this will support 5 meter from one side, and this is 8, so it will support 4 meter from this side. However, this guy here will support only 4 meter. Okay, and that's why it's very little. The load is very little, and this guy will even have more than the one on the right, because half of the 10 is 5. So this will simply take care of 5 meter, and this will take care of 4 meter, and this column here will take care of 9 meters, 5 from the left and then 4 from the right. You guys remember dimensions, huh? Dimensions between here to there, it is 10. Dimension from the middle to the right is 8 meters, okay? And that's why this makes sense for you. Okay, now you can show the formation. So if you go back to, you go back to here. So, okay, you know what? No axial force. Show me internal forces. Apply. Hit OK. Now, you can see, yes, I can see the deformed shape, but I can see the numbers. Like, can I see the numbers? Okay. So obviously on this diagram here, we don't see the numbers. If you want to get the number in millimeter, okay, let me show you. For example, I'm going to go back and I'm going to, you know what, do that. So forget about 1.4D. And because I'm looking at deflection, I don't care the deflection for the ultimate limit state, because your beam is about to fail. So we're not really getting deflection from this load combination or this or this or this or this. The deformation, we get it from number 6, number 7, number 8. Those are serviceability. From 1 to 5 are ultimate limit state. Okay, so let's mark 0.75 wind lift and say apply and hit OK. So this is my load combination. If you come to here, okay, and you go to displacement, joint displacement, so you go to that second icon after the check, you can simply show numerical. It means by numbers, not by shape. Okay, and you can see we can do the same thing for every element here. I can go to joint displacement, and I can say all structure under 0.75 wind lift, all structure, and then let's hit OK and see. So this will create for us here kind of an Excel file that tells you the displacement of every point under load combination wind lift. And you can see, for example, point number 2 will simply move this much in the X and this much in the Y and this much in the Z. And point number 4 and 5 and 6 and so on. Now I'm going to show you guys. Now some of you will say, okay, so where is joint number 2? Where is joint number 3? Obviously here I need to show the joint number. Any help on how to show the joint number? Anybody who followed the discussion so far, tell me how to show the joint number? Okay, Mahdi, where? What do you think? Where from the software I can show the joint number?
Go to display options.
Thank you, sir. Exactly. Anytime you want to control the display, you go to display options. So you go from menu view, display option, and you can see. Remember, we're not talking about scales or text or size or color. We're talking about visibility. We want to show, and then you can see under those items here there is joint. And so what happened is I think the joints are shown. So let me go to the text. I think I'm wrong. So I was referring to the ID. Okay. So I go to the text and again joints, and you can see right now it says show ID. It is unmarked. It means don't show me. However, if I click on this one, it will show ID. If I click on this one, it will show coordinates. And to be honest, I'm not interested in coordinates. So I'm going to say ID, apply, hit OK. Congratulations. This joint number 1, number 2, number 3, number 4, number 5, number 6. And you guys, now if you go back to your table, you should know, for example, under this point load combination, you hit OK. And guess what? Point number 2 will move 2.3 millimeter to the left. So this value here from this point is only 2.3 millimeters. Okay. Now last, and then we're gonna break. If you wanna show not in a tabular format, not in table format, you wanna show the graphics for individual member, like the bending moment or the shear or whatever for an individual member. Your last element is, or last button is this one here. This one here, you click on it, you say, for example, internal forces, and then you get this handle. You can see the cursor has changed to a handle, and then all you have to do is you just hit a member that you want to get all the internal forces in a graphical format. So we click here, and you can see we have all the internal forces for the member I hit. For example, if I click on MZ, so you can see at the bottom here, we see all the values of the bending moment, not only at the maximum, but you can see every meter. Look at the table, like Excel, 0, 1,000, 2,000, 3,000, 4,000, all the way to 10 meter, because the length of this beam is 10 meter. We know the internal forces, MZ and MY, all those ones, okay? Okay, guys, let me ask a question before the break. If you have used the tutorial on the D2L before you come to today's class, show your hands. Don't be shy. Okay, show your hands. If you used the tutorial on the D2L for the SAFI before today? Show your hands, please. Only 2. Okay, guys. Okay, great. Thank you so much. Now, if you used the tutorial, what do you think? Is it easy to follow? Is it detailed, or it's missing something?
I think it's relatively easy to follow, but it's just better to have you here for questions. Like sometimes when I was going through it, I didn't understand what was happening and why. But as far as it goes, as like putting everything in the program, it's very helpful.
100%, 100%. I 100% agree. In the tutorial, and that's like for the software, nobody will give you the sense of the structure, how it moves, how do you find. So those are kind of discussion I always would like to keep it to my class. Otherwise, there should be, so the steps are in the tutorial, but the engineering sense on how to analyze the structure, you have to get it from me, from Tahir in class. Ask questions, listen, hear, feel it in class, not in the tutorial. Okay, so they complete each other, I guess. Now,
I was looking for the tutorial for the recorded video last topic, the first part of this tutorial, but I couldn't find it in the Teams.
so if you just touch, like catch like with me after the class, we will work on that one. Anybody else has a problem to access the last class tutorial, like the recording, or nobody really until now? Because there is no assignment. I know guys, you work only when you have an assignment, but if you don't have an assignment, probably not, right?
You got it right.
Okay,
I'll mark you
so
5.
anyway, so I mean, again, like connect with me after the class by 3 p.m. and I'll just make sure that you have access to the tutorial if there is any. I know one class I kind of missed the first part. I kind of forgot to hit the recording button. So I'm hoping that this is not the one that you have problem to access. Okay. Okay, guys. I think it's too long today. It's 1 hour, 1 hour 15 minutes. So we'll break for 10 minutes. We'll see you back here at 2:25. Thank you.